All right, this is lesson 921, problem 944. If we were in school and we were doing this in class, we would be representing these inequalities with a human number line. Since we're not, I will show you how to graph them on actual number lines. So problem A is x is greater than or equal to -2. All right, so I'm going to set up my number line. And then I'm going to look and see what's going on here. So my boundary point, so the smallest number that x can equal is -2. And since we have this line under the inequality, that means x can equal -2. So I'm going to put my circle in -2, and since x can be equal to -2, I'm going to fill it in and make it a solid circle. And then this reads x is greater than -2. So the numbers that are greater than -2 are all to the right on my number line. So I'm going to draw an arrow going to the right. Problem B says that x is less than or equal to 1. So I want to represent that on my number line. Okay, the boundary point, the smallest number that x can be equal to is this number we're given here, so it's 1. And since this is x is less than or equal to, remember that's that line underneath the inequality means equal to. So I'm going to go to my boundary point, which is 1. And since x can equal 1, I'm going to fill in that circle with a solid dot. And then x is less than or equal to 1. So the numbers that are less than 1 are to the left on my number line. Okay, problem C is x is equal to 3. All right, so you might be noticing that this looks different than the other ones we just did. It is not an inequality, it's actually an equation. So my boundary point's at 3, and x is equal to 3, so solid dot on 3, and that's it. X can only equal 3. There's no other possibilities for x to be, so we will just have a solid dot on x equals 3. Problem D is x is greater than or equal to 0. So on my number line, okay, I know my boundary point is at 0, so I know that's where I'm going to put my circle. Since it's x is greater than or equal to 0, x can equal 0, so I'm going to fill that circle in. So x is either equal to 0 or it is greater than 0. Numbers that are greater than 0 are to the right on my number line, so I'm going to have an arrow going to the right. Problem E, x is equal to -2. So hopefully you're noticing that this one is not an inequality, it's an equation. So from the last problem we did like that, you might be thinking, okay, this is going to be one dot on x equals -2, and it's going to be a solid dot because x equals -2, and that is the only number x can be. Okay, problem F. Now we have -1 is less than or equal to x is less than or equal to 4. Okay, get my number line set up. Okay, in this problem we have two boundary points. We've got one at -1, so I'm going to put a circle there, and we have one at 4, so I'm going to put a circle there. And then now I need to decide if I'm going to fill in those circles. Since these both have the equal to line underneath the inequality, I'm going to fill them in. Okay, and now if we were in class, I would cover up part of this equation or this inequality, so I'm going to try to do that So I'm going to pretend like what I did in brown there, you can't see that, okay? And let's look at the part we can see. Starting with the variable, starting from the x, if I'm reading, starting with the x, I have x is greater than or equal to -1, okay? When I start reading with the variable, x is greater than or equal to -1. So numbers that are greater than -1 are this direction, okay? I'm going to do that again. I'm going to cover up the other side. Okay, so now pretend we don't see what's in brown and we just see the other side. Starting with the x again, now I have x is less than or equal to 4. So numbers that are less than 4 are this direction. Okay, so our solution is the numbers here now between -1 and 4 and also -1 and 4. Okay. So I don't have any arrows in there because they don't go beyond -1 and 4. It's just the numbers between -1 and +4, including -1 and 4. All right, taking a look at G, we have x squared is greater than or equal to +4. Okay, so I'm going to just draw my number line over here. I'm going to draw out a couple things here. Okay. So, oops, let's make it 3. Okay, so if these are my x values and I'm squaring them, okay, because we know that we're doing that in this inequality. So 3 squared is 9, 2 squared is 4, 1 squared is 1, 0 squared is 0, -1 squared is 1, right? -1 times -1 is +1. -2 squared, -2 times -2 is 4. And then -3 squared is +9. Okay, so in this problem, it says when we square x, okay, when we take our x value and we square it, we get a number greater than or equal to 4. Okay, so x can be any values that when we square that value, that number is greater than or equal to 4. Okay, so if I look at my x values here, when I square, let's start with 0. When I square 0, I get 0. That is not greater than or equal to 4. So that can't be part of my solution. Okay? When I square 1, I get 1. Well, that's not greater than or equal to 4. So that 1 can't be part of my solution. How about 2? When I square 2, I get 4. That's equal to 4. When I square 3, I get 9. That's greater than 4, okay? So my boundary point for this side is going to be on 2, a solid dot, because I have this equal to. So when I square 2 or a number bigger than 2, I get numbers greater than or equal to 4. So think about it. 2 squared is 4, equal to 4. 3 squared is 9, that's greater than 4. 4 squared is 16, that's greater than 4. Okay, but when we squared 1 and 0, we didn't get a number equal or greater than 4. Okay, let's look at some of these negative numbers. Okay, when we squared -1, we got 1. That's not greater than 4, so that can't be part of our solution. When I squared -2, I got 4. Okay, so that's my boundary point for the other side of this, and it's solid because -2 squared equals 4. When I squared -3, I got 9. That's greater than 4, okay? So all of these numbers that are off to the left here, when we square them, we will get a number greater than 4, right? -3 squared is 9. That's greater than 4. -4 squared is 16. That's greater than 4. So that's what our solution looks like for this problem. We've got our solid dots on 2 and -2, and then our numbers that will make this inequality true are going to go off to the right of +2 and off to the left of -2. All right, let's take a look at one more at h. We have x is less than -3. Setting up my number line. Okay, I know my boundary point is at -3, so a circle on -3. Now this circle is not going to be filled in. I don't have that equal sign underneath the inequality. All I have is that x is less than -3. So numbers that are less than -3 are to the left of -3 on the number line.